Hello everyone, my name is Timothy Hansen, and in today's MAXDEPTH tutorial we will be discussing Alembic pipeline workflows, specifically relating to the use of Realflow 2014 to create Alembic meshes and particle caches that we will then import into Maya using Vray 3's Proxy import system. In addition to giving you a quick walkthrough on how to set up a Hybrido simulation, we will discuss using Export Central and Realflow 2014 to export our Alembic files with all the necessary channel information to carry over into Maya, allowing us to render with full motion blur using Vray. We will also cover a few tips on how to diagnose and clean up the noise in your renders, as well as setting up render passes in Vray 3 for Maya. Okay, so now getting started here in Realflow 2014. I'm going to first make a couple of spheres. One I'm going to use as a colliding object and one as an emitter. So the first one I'll offset and scale it up, and the second one I'll scale up slightly and then put it just underneath the first. And so what I'm going to do is use the smaller one to emit, to splash off of the first one to give us sort of a water spray. So first let's make the Hybrido domain. Just increase it just a little bit. And then now I'm going to make this second sphere an emitter. And the first thing I need to do is to make it stream, and we want it to have constant velocity. And now we're going to keyframe the speed. But first let's rotate it to get the direction that it's going to emit from, because I want it to aim and splash directly against the first sphere. Okay, reset. We're going to add a key because we want it to stream, but I'm only going to do it for 10 frames just because I just need this to be a quick example. So go to frame 10, set another key, and go to frame 11, and then end the stream and set another key. Okay, and then same thing. I've made my velocity constant, and I want to set a key at 0 on frame 11 because I want it to stop at 11. And at frame 10, I want it to have an initial speed, so let me first try a value of 10. This probably won't be enough, but let's just check it really quick. And add our other key. Set our timeline back to 0. We're streaming, we have speed, we're constant. And let's add a gravity. Okay, 9.8 real world, that's fine. And next thing we want to do before we simulate is go to Export Central. And now in here, I just want to go to the Hybrido domain and I want to activate our Alembic output. Now, normally you would run it with GFC and RPC because then that way you can use those to come back and generate your secondaries like splash and foam. But for the purposes of this tutorial, I'm only interested in the Alembic. So let's take that on and then tool down to its options, and we want to make sure velocity is on. That's the most important thing. And let's add vorticity and normal. Just tick them all on. And so now we have our Alembic file format, and we don't need the displacement for this. And now we're ready to simulate. So let's close out, reset our timeline, and simulate. Okay. I think, yeah, that speed of 10 is not going to be enough. We're going to need to increase that. So let me come back in, reset our timeline, go back to our emitter, change our speed to 40, set the key again, and simulate. Now we're getting much more output. This is going to work for us. Okay. Let's let it run off 10. And you can see we've got a nice splash formation coming here, water spray. So we'll stop simulation and just twill around. It looks good, but I want it to be a little bit more dense than it is. We want the particle count to be a little bit higher, just for simulation's sake later on when we get into Maya. So to increase the density, I'm going to need to come back to our domain, and I want to make this dense. I want to also reduce our cell size to increase the resolution. Lower is higher resolution. And I want to conserve volume. Okay, and let's simulate again. And that's much better. Much denser particle cloud. This will look good when we render just as particles, and it'll also help increase the quality when we mesh this. And I'm happy with this particle count. I could probably mess with the jitter and things like that to reduce that stepping. But again, this is just for quick example sake to show the Alembic workflow. Okay, so now we want to create a Hybrido mesh. And again, go to Export Central before we do any simming. I want to turn off bin and turn on Alembic. And all of its proper channels are already enabled. Click Done. And we just want to change a few parameters over here. Now, I want to decrease the polygon size and decrease the particle radius just a little bit because I want it to have a little bit of a higher resolution. I want to reduce the core smoothing filter slightly and also the core threshold, and then increase the smoothing steps just a bit, and then build. Okay, so now let's hide the domain so we get rid of our particles, hit 0 so that we can see a meshed version with spec and things like that on. Okay, so this will work for us. I want to make just one or two little tweaks, and then we'll move on into Maya. So I want to increase the particle radius just slightly. The polygon size is fine, but I just want to thicken this up a little bit because it's a little sparse. And yes, that's a 0.125. And then we'll build again. And you'll see that the mesh itself will thicken a bit. There we go. Okay. And that's looking better. And just really quick, I'm going to do one more tweak to our filtering just because I want to thin it out just a little bit. It's a little too blobby. So I'm just going to come down to our thinning size and our core threshold and decrease those just a little bit more. Okay, perfect. This will work for us. So we've got a little bit of thickness, but it's not too blobby. The mesh is pretty even. It has some sheeting. It's nice. So we want to set our domain to cache, and our emitter, we can just turn him off because we don't need him to emit anymore. And then let's simulate out. Let's reset to 0, but don't do reset. And then go simulate. And then it will use the cache data from the Hybrido domain and mesh all those particles that we had created previously. So just let this run for a second, and we'll be able to move on into Maya. Okay, so now we have our timeline completely meshed. So we have our particles and we have our Hybrido mesh. So now we want to stitch these together, and we want to go to Tools and then Stitch Alembic. And what this does is it takes the image, the Alembic sequence that we created, and it makes it one Alembic file, which is going to be important later on in Maya, so that it runs the animation, and then it also has data ahead of it and after it for the motion blur calculation. So we'll just select the sequence that we want to stitch together. We'll give it an output file and file name. Let's just make a new folder, ABC. And then in that folder, we'll just call this ABC Vray stitch. And stitch. and then that'll run for a minute, and now we're done. Okay, and now let's go back and let's stitch our particle sequence, because we also want to test this Alembic workflow for particles as well as meshes. Okay, so let's select our sequence from 1 to 10, just because that's what we did with our mesh. And let's stitch that in the same fashion. Let's make sure we put it in a new folder. Particles, ABC, and then we'll just call this one ABC stitch. Okay, alright, so that's done. And now let's move on into Maya. Okay, so now back in Maya, we're going to import these files, and we're going to show you the major workflow problem that you'll run into if you're using the pipeline cache through Maya. So all I did is I put in a light dome, and we're going to go to pipeline cache and import this through import Alembic. Okay, and search to a folder, and then here we have our stitch file. So let's import this and scrub the timeline. And there we go, we have our Hybrido mesh Alembic file. So now we see everything has been imported fine. Let's put a just standard Vray material on this guy. We'll just put together a basic, refractive water. We'll just call this water. Take the diffuse color, put that down to black. We want to turn on reflection, but we don't want the glossiness to be a perfect 1. Let's put it down just a tick under. Increase our reflection subdivisions to 16, just sort of a baseline. Turn refraction all the way up. Also, our refractive IOR has to be 1.3 for water. Increase refraction subdivs, and then also take the refraction glossiness down just slightly. Okay, now that we have our basic water, let's input just sort of a basic set of Vray render settings that I use for the majority of scenes. Set our image format to EXR, image format options, set that to 32-bit. Close that. And we want to render an animation, but only in batch mode. And everything else down here is fine. We'll just convert image to sRGB and open our Vray frame buffer. Okay. So the first thing, let's set our bucket size down to 32. And our dynamic memory to 0. I actually have a good deal of RAM in this machine, so by setting it to 0, it'll use all of the available RAM. And then let's add in some passes, just so we can check and find where our noise is. So diffuse, sliding, matte shadow, normals, reflection. Sample rate's going to be a good one that we're going to use to check our noise. Shadow spec, and Z-depth. Again, just a standard complement, nothing special. But let's get some information for our Z-depth pass. You can see here distance from camera. Let's select our mesh, and we know that we are basically 41 units from the camera. So we go to our Vray attributes and set our depth white just slightly above that. Just make it 100. Okay, bring back our Vray frame buffer, and let's render this frame. So out of the box, we're looking good, and then let's check our passes. Alpha's good. There won't be a diffuse because it's a purely refractive, clear material. Cycling through, reflection, looks good. Our sample rate, now we're going to pay attention to this in a minute. We're going to use this to determine where we need more samples to increase our quality. And our z-depth pass is looking good. So, alright, so all of our passes are in and good. Let's tweak this. So save that image for comparison later on. Okay. And now let's go back to our render settings. So the first thing we want to do is let's activate our motion blur, because this is where, and we'll leave it pretty standard, but this is where we're going to find the error in the pipeline cache Alembic workflow. Now you'll see we've turned on motion blur, and as it's rendering through, you'll see that there is no motion blur being calculated at all. It will render an identical image whether you have motion blur turned on or turned off when importing Alembics through the pipeline cache option. Now what we're going to want to do is not use Maya's native pipeline cache Alembic import. We want to use Vray's proxy menu, because Vray's proxy import will read not only VR mesh files but Alembic files in Vray 3. So let's close the render settings. And then let's delete this mesh and now go up to the Create, Vray, Import Proxy. Now let's name this Realflow. And then let's surf to that same Vray stitch file, ABC Vray stitch file that we were just looking at through the pipeline cache. Nothing different, it's the same exact file, we're just importing it through the Import Vray Proxy. And now you'll see a great thing about the Vray Proxy and importing through there is you get that functionality where it reduces the size in your viewport. So you still get the silhouette, but it's not as taxing on your video card, which is a great thing when you have super dense scenes. But you can still see the whole mesh by coming over here to the right and ticking Show Whole Mesh up at the top. Give it a second to calculate, and there we go. Now we have our full mesh again in our viewport. It's the same exact file, no difference. But I usually just tick this off just because, again, it makes my viewport navigation much easier. So as you see, we stitched the file, so now we can scrub it. It's an animation, it'll play back. And usually, just to be safe, I always tick the Use Alembic Offset and playback set it to once. Otherwise, it'll loop around and continue to play. So let's attach our water shader, the same as we had before, and render again. And now we'll see motion blur being calculated. And we do. So that's the trick. The Alembic workflow, it's a great way to transfer data sets from software to software, but the only way to get motion blur is to go through the Vray proxy and not through Maya's native pipeline cache. Again, Maya's native pipeline cache will not calculate the motion blur for you, but Vray will. And as an added benefit of using the Vray proxy, everything just loads better, and it's less taxing on your machine, so your render should come out a little faster. And now I just want to tweak a little bit of the settings, a better sample rate. Now for me, I want to decrease this motion blur just a little bit because just for my taste there's too much. So we'll put to 0.5, and I want to put the interval center to 0 and bias to 1. That way the center of mass will be at the point of velocity for the droplets, leaving the trail of motion blur behind. And now I'm going to increase the min subjects to 2, the max to 32. I'm going to put our threshold, which covers our noise, to 0.06 because I want to reduce as much noise as possible without, sending render times through the roof. We always want an animated noise pattern, and our motion blur is set. And one more thing that sometimes happens with water type renders, you'll get sort of hotspots and fireflies. So let's clamp our max ray intensity and that will eliminate those sort of like speckly fireflies. I don't think we're going to get it on this render, but just in case, for these types of simulation renders, I always turn on clamp max ray. And again, this isn't a Vray, render setting tutorial, but these settings basically will cover 90% of anything you could possibly render. So let's render again. And now this render is going to take a little bit longer because we've increased our samples, but we need to get rid of that noise. Let me take a look as it's rendering, and let's go back to our sample rate, and we can see now that where there was solid red, we're starting to get some of those greens and blues in there, which means that our sampling is in a little bit of a better position. Now, the one thing with sample rate is you could keep increasing the samples until everything's blue, but it's not necessary in most cases. As you can see, over on the left, we're much smoother and much cleaner. All right, so now we're looking much, much, much better. Our motion blur isn't going crazy, and our sample settings are much cleaner. You'll see our original to the right with no motion blur, and our motion blurred version on the left, and everything looks great. So that's how you do it. It's a simple thing, but you can easily get tripped up on it. And again, keep in mind, it took us about 6 minutes to render this frame, which is not bad at all. But without motion blur, it took us just under 50 seconds. So anytime you add motion blur, it's going to increase your render times. And keep in mind, we also increased our render settings to get rid of noise. So you'll just have to find the balance that works for you. But 6 minutes a frame on a completely refractive, motion blurred surface is pretty darn good. So now, let's see if this workflow will also work for just particles instead of meshes. It'll work for particles as well. So let's call this one Realflow Particles. And we'll surf to our particle version. And there we go. You just have to scrub back and forth a little bit. And the same as our mesh, we have our particle sim. So if you're not meshing your Realflow sim or whatever software you're using to create your particles and particle meshes, you can import particles as well in this fashion. And also the show mesh feature works in the same way. So we'll use the animation offset tick box, and we're going to render it just with the default of spheres. And so now your particle width multiplier, this is going to be the most important thing for you when rendering particles in this fashion with Alembic. Now, let's turn off our motion blur just to start, and click render. And the first thing you'll notice is by default, our particles are rendering as huge, huge spheres. And we can easily take care of that in just a second. So yeah, you'll notice on the left we have what our particle sim should be, what we want it to be, and on the right it's rendering thick. And why is that? Well, it's this particle width multiplier. So let's decrease this value by a lot. Let's say 0.1. I think we're still going to need to go smaller than this, but just to illustrate the point, taking it down by a factor of 10, it should get us a lot closer to what we're imagining we would be getting. So yeah, so it decreases the size by a factor of 10, but I think we're still going to want to go a bit smaller just to get the look that we're going for to match our particles in the viewport. So let's try 0.02, and this should get us where we want to be. And it does. It's perfect. Now we're looking like what we're hoping to look like. A nice, small, fine particle stream. Okay. And I just want to add a quick directional light just to fill in the light a little bit, because these guys are so small. I want them to show up a little bit better. Okay, let that run through. And now we'll have a little bit more clearly defined particle sim. It's a little extra light. Okay, and again, full complement of passes, lighting, shadow, everything you could need. It inherits from the Alembic file. So again, this is a workflow that'll work great for us. And now, the big test, let's throw on motion blur. Okay, we'll leave our settings as we had them before. Click render. And do we have motion blur? Yes, we do. So perfect. Again, when using Alembic, it's an amazing file transfer protocol that works great between software platforms. But inherently in Maya's pipeline cache import, it doesn't calculate for the motion blur. I'm sure there's some way you could script something and work it out, but on a production, I want something that's plug and play, that's like as few clicks as possible. And so going through the Vray proxy object, it works out of the box, simple. So we have particles with motion blur, we have meshes with motion blur, and it's all thanks to Vray proxy import. So thanks for watching, and we'll see you next time here at MAXDEPTH. Thanks.